Hello and welcome to Module 11, Video 3 on IP addressing. So don't forget to write down everything and submit them when you're all done. All right, so we're going to start talking about the logical AND, the logical AND. The logical AND, remember we talked about on the last video that the routers now are no longer going to are not going to be classful, which means they're no longer going to look and see if the IP address, what class the IP address is in to figure out the network address. So what they're going to do is they're going to take the IP address and they're going to have a mask them. We call that a subnet mask. And then what they're going to do is they are going to mask the destination IP address to figure out the network portion. So they're called classless because they don't need to know what classes the IP address is in. They're going to use a mask instead. So the process of masking is you do what's called a logical AND. What is a logical AND? Let's talk about that first. So a logical AND is really a gate, an electronic gate where it has two inputs. And if both inputs are zeros, the gate output, let me just push this over. The gate output would be zero. If it doesn't matter if input X and input Y is alternating, one's in 0 or 1, the output will be 0. The only time that the output will be a 1 is where both inputs are 1s. So it's good to remember that. So for example, if I want to AND this number with this number, X and Y numbers, so what you do is you take this number, just write it down this way, and write the Y right underneath it. And when you AND them, whenever you see two ones, the result is a 1. Anything else, if they are alternating, 0, 1 or 1, 0, the answer is 0. And if they're both zeros, it's also 0. So in this case, you get a 1 here, you get a 1 there, you get 1 here, and that's it. And then the rest is 0. So this is your result after ANDing. So you get 1, 0, 1, 0, 0. Okay? All right. So let's try the following. How do you AND 192 with 255? Well, when you take if you take this and AND it with 255, what happened is if you see 1 and 1, you get a 1. 1 and 1, you get a 1. And a 0 with 1, you get a 0. And therefore, rule number 1. So whenever you AND with 255, so a number ANDed with 255 always gets you the same number back. In this case is 192. Is that clear? And here is rule number 2. So we don't even have to move forward. If you AND anything with 0, the answer will be 0. So remember these two rules. Anything that you AND with 190, anything you AND with 255, you get anything. You get the same number back. Anything you AND with 0, you get 0. Now, anything you add with this, anything else, there's going to be a different number in this case. All right. So how would you? Let's do here. So 165 is this, right? 224 is 3 ones, and when you AND them, you get 160, right? So when you AND 203, 203 converted to binary is this, and 0 is all zeros. So when you take bit by bit, just like we did up here, you'll see that all the bits will be 0. Okay? So remember, 203 is 128 plus 64 plus 8 plus 2 plus 1, right? All right. So remember this. Whenever you AND with a number with 255, you'll get the number back. And whenever you AND with 0, the result will always be 0. Okay, so let's try ANDing this IP address with this mask address. This is going to be a mask address. Okay, so you're going to get an IP address and you're going to get a subnet mask address. So what you do is when I say that the router is taking the IP address and masking, so masking the IP address with the subnet mask address, what they're doing is they are doing a logical AND between the destination IP address and the mask. And when they do that, what do they get? 192 ANDed with 255 is what? 192. 168 ended with 255, you get the same number back again, 168. 10 ended with 255, you get 10 again. But when you end 165 with 224, you get 160. Okay, so you want to see that? So here is 165 in binary, 101, that's 160, and you need a 5. So a 5 is what? 0, 1, oops, 0, 1, 0, 1, right? And 224 is 1, 1, oops, 1, 1, 1, 0 with 1, 1, 1, 1, right? And what's the result? Remember? Oops. Okay, let me just go over here. So what do you see on the top? 1 and 1 is a 1. 0 and 1 is 0, right? 0 and 1 is 0. And then 1 and 1 is 1. And then what do you get? You get 0. 0, 0 is 0. 1 and 0 is 0. 0 and 0 is 0. 1 and 0 is 0. So what do you see here? The result is the 128 plus 16, and that's equal to 160. And you take that number and you put it at the end, because 165 ended with 224 is equal to 160. So this would be the network address. When you take the IP address and end it with the mask, what you're doing is you're masking the host portion of the IP, revealing the network portion. All right, now, typically we'd like to write the mask using a slash format. So this is indicating how many ones do you have here? In this case, 8 plus 8 is 16 plus 8 is 24, and 224 has 3 ones in it, right? So 224 plus 3, so this could be written as /27. Okay, so the mask could be written as a /27. All right, so how do you do that? So we need to be able to write these numbers in slashes. So /13, for example, like I said earlier, I think on the last video we did this, is you have 13 ones. So you write 13 ones, and then the rest, to get to 32, you write them as zeros, then you convert to decimal. So this is 8. If you convert this 8 ones is 255. 5 ones with three zeros is 248, and then 0, 0. So /13 is equal to that. All right. Oops. So here's also another example. But even, if somebody gives you a slash and says, write that in decimal format, you can write, this number indicates how many ones, and you stop, and then you write the rest zeros. You stop at 32, and then just convert the numbers back to decimal. But typically what happens is when you are writing a slash in decimal, the first number is going to be 255s, and you keep writing 255s maybe, and in the last byte, there's going to be some extra ones, some leftovers. So what I did is, to make it a little bit easier, if the leftovers are all zeros, then you'll write that decimal point to be 0. If it's just the 1, it's 128. If it's 2 leftovers, it's 192. If it's 3 and 224, and so on. So if you have /24, so you say to yourself here, I'm going to write it out for you. You're going to say to yourself, it's 8. There's 8 ones. Plus 8 is 16. Plus 8 is 24. Perfect. There's no leftovers. There's 0 leftovers, and 0 leftover says put a 0. So you put a 0. All right. So let's look at. I'm going to erase this. I'm going to show you how to do it. So let's /12. So that means /12 is, here's 8 ones. All right. If I write another 255, that means I'll be 16. That'll be another 8. That's not good. So how much is left over? 8 plus what is equal to 12? Plus 4. So there is the 4 ones, right? 4 is 240. So you write 240. Because you had a leftover, you're done. So then you write 2 zeros to make sure that you have the 4 bytes, right? So let's do /18. I'll write it over one more. 8, 16, There's 2 left over. If you look up the chart, 2 left over is 192. So you'll write 192, and you got to have 4 bytes, so you'll write that 0. Slash 16, 8 plus 8, 0, 0, right? Slash 27, 8, 16, 24, 3 leftovers is 224, right? And slash 8 is this, 255, and that's it. So for class C to be backward compatible, it's slash 24. For class B, slash 16. And for class A, it's slash 8, right? So we no longer need classful IP addresses. We're always going to write a mask. So from now on, we're not going to write the mask this way. We'll write it with a slash. You should be able now to convert it back. All right? So now let's do an example. If somebody asked you, what is the network portion of given this IP address? So what do? You take this IP address, you write it out, and you end it with slash 27. So what's slash 27? 8 plus 8 is 16 plus 8 is 224. And there's 3 left over, right? So 192 ended with 255 is 192. 168 ended with 255, you get 168. 10 ended with 255, you get 10. 170 ended with 224. You got to do it on the side. Here's 170 ended with 224. So when you do 170 is converted to binary, 224 converted to binary. 1 and 1 is 1, 0 and 1 is 0, and so on, blah, blah, blah. You get 160. Now, by the way, here's where the masking. You see this 224, these zeros? Masking, this is the host portion of the IP, because the first 27 bits is your network portion. So your network portion is 192.168.10, and 3 more bits from the 170, which is the 101. This is the host portion of the IP. So in other words, this is really a host in the network 192.168.10, and then 3 bits from here. So what the mask does is it makes the hosts all zeros by force. That's what masking means, is making the host portion of the IP equal to 0, revealing the 3 bits of the network and the other bits that are left over. So the network portion would be, when you do the ending of 170 and 224, the result will be 160. So the network portion is 192.168.10.60. Now take a note. The network portion doesn't end with 0. So it's not necessarily, if you heard that, that's not always true. This is a network address. Remember, it's a slash 27. So this is a network address. If you were to type this IP address on a PC, the PC will reject it. Why? Because it's a network address, and we'll discuss that later on. A network address cannot be assigned to any host. All right, so moving on. We'll stop right here, and then on our next video, we are going to talk about the special IPv4 addresses. So write down whatever I asked you to do, and then we'll continue on the next video.